This is section 5.2. So we have all these problems going up to problem 41. So let me go ahead and show those to you. Page 388. So here we go. You see the expression Riemann sum. What we've been doing is Riemann sums, adding up base times height, base times height, base times height, areas of rectangles, adding them all up. That's called a Riemann sum. 3, 5, 6, 7, 9, 11, and at the end, 33, 34, 35 to 41. Then you probably notice there's an integral sign that I used already, but there are numbers here. Okay, so these are called definite integrals before they were indefinite integrals. All right, so for definite integrals, you'll see a number at the top and bottom of the integral sign. And I'll talk about that in turn, what it represents. Okay, 5.2, number 3, f of x is x squared minus 4 between 0 and 3. Okay, n equals 6, and they ask us to choose the midpoints. So it says find the Riemann sum, number 3. Riemann sum means approximate the area under the curve, quote unquote. That's it. Last section, we only had positive functions. If the function is negative, then the region bounded by the x-axis and the function would be negative because the function values are negative. All right, so here's the graph of the function. I chopped the region up into 6 pieces because they told me to, so delta x is 0.5. So when I go base times height, some of the heights are actually depths. You're actually going down, so the function values are negative. Some are positive, so it looks like there's going to be a cancellation, some positive, some negative. In this particular case, it looks like there's more negative than positive, so I'm expecting the Riemann sum, the estimate, to be negative. So M6, using midpoints and 6 subintervals. So delta x is 0.5. F of the midpoints are 0.25, f of 0.75, f of 1.25, f of 1.75, f of 2.25, f of 2.75. Okay, then I plug all of these 6 numbers into the function x squared minus 4. So 0.25 squared minus 4 is that. And then 0.75 squared minus 4 is that, all the way down the line. So it looks like 1, 2, 3, 4 of them are negative. The last 2 are evidently positive. The net result is a negative number. So negative 3.0625. Okay, so the Riemann sum is sort of like giving you the signed area, SIGNED, where anything above the x-axis is positive, anything below the x-axis is counted as a negative. Number 5, he wants to take the region between 0 and 10. Okay. N equals 5, delta x is 2. So delta x is 2, the subintervals are from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. We're using left endpoints, right endpoints, and midpoints. Okay, so I've got them all there. So between 0 and 2, left endpoint 2, right endpoint -1, midpoint. So let's see if I got the right thing here. Okay, so this may be different than what's in the text actually. Oh, I see. I'm just labeling what the left right endpoint and middle points are, right? So left endpoints are 0, 2, 4, 6, 8. Right endpoints are 2, 4, 6, 8, 10. Midpoints are 1, 3, 5, 7, 9. So this is delta x, and these are the function values, right? Okay. So 3, -1, 0, -2, and 2. And this is clumsy because I can't show you both at the same time. The left endpoints were 3, 0, -1, and I forgot what the others were, -2, and 2. So that comes out to be 4. Right endpoints are the function values at 2, 4, 6, 8, and 10. So the function values, sorry, I can't show you both at the same time, at 2, 4, 6, 8, and 10 are evidently -1, 0, -2, 2, and 4. It comes out to be 6. Then M5, function values at 1, 3, 5, 7, and 9. So the function values of this graph at 1, 3, 5, 7, and 9, you can verify it on your own later, are 0, -1, -1, 0, and 3. That comes out to be 2. Okay, and I want you to notice the notation for number 5. Okay, the integral from 0 to 10 of f of x dx, I have no more hands, so I can't show it to you, but look at number 5 across the top line. Integral from 0 to 10 of f of x dx means the true signed area where the function above the x-axis is counted as a positive area, the function below the x-axis is counted as a negative. So the true value of this is everything under here and here minus this region bounded by the graph on the x-axis and this region bounded by the x-axis. That's what that symbol means. The exact value, which right now we can only approximate. Okay, 7. Notice again the notation. Integral from 10 to 30 of f of x dx. Okay, the net area above the x-axis looks like there's some that are negative and some are positive, going from 10 to 30. So it looks like delta x is 4, 10, 14, 18, 22, 26, 30. Lower and upper estimates. This looks like an increasing function. So for lower estimate, I'll pick the left endpoint, and for upper estimate, the right endpoint. So the graph goes from -12 to -6. The lower estimate we would pick -12. From 14 to 18, from -6 to -2, lower estimate we would pick -6, and so on. The last subinterval from 26 to 30, it goes from 3 to 8. To get a lower estimate, I picked the 3. And similarly, for the upper estimates, it looks like I picked the right endpoint. From -12 to -6, the larger number is -6. From 14 to 18, the larger number is -2, and so on. So lower estimate is 4 times the left endpoint, -12 plus -6 plus -2 plus 1 plus 3, -64. Upper estimate, the delta x for the right endpoints, -6, -2, 1, 3, and 8, comes out to be 16. Okay, notice there's a match because the left endpoint for one is the right endpoint for the other, for all of them except for the very first one and the very last one. Okay, 11, give an estimate of the integral from 0 to 2 of x over x plus 1 dx for n equals 5. Okay, so this symbol means give the true area under the curve from 0 to 2. Right now, we don't know how to do that. We can only approximate. Okay, so from 0 to 2, that's 2 units divided by 5. So delta x is 0.4. They told us to use midpoints. So here we are, 0, 0.4, 0.8, 1.2, 1.6, 2. Here are the midpoints, 0.2, 0.6, 1, 1.4, 1.8. Okay, so M5, using midpoint rule, chop into 5 pieces, integral from 0 to 2 is approximately delta x 0.4 times the function value at 0.2, 0.6, 1, 1.4, 1.8. Caution, don't plug in these numbers. You want the function value. Okay, the function was x over x plus 1. So 0.2 over 1.2, 0.6 over 1.6, 1 over 2, 1.4 over 2.4. I'm plugging all of these guys in here. 1.8 divided by 2.8. Add them all up. So our approximation for this integral, which in this case is positive, so it's the area under the curve, is approximately 0.9071. Okay, going back to 5.2, number 1, approximate the integral from -6 to 4 of x minus 1 dx. Here's the graph of x minus 1 from -6 to 4. So the true value that we're asking for this integral from -6 to 4 is everything here counts as a negative, and this tiny piece here counts as a positive. So it looks like the answer ought to be negative. All right, and in the question, they asked us to use right endpoints, which means from -6 to -4, I pick -4. From -4 to -2, I pick -2. From -2 to 0, I pick 0, and so on. The function is x minus 1. Okay, so at -4, subtract 1, I have -5. Picking the right endpoint. -2, plug in the function -3. 0 gives me -1, 1 gives me 1, and 4 gives me 3. Delta x is 2. Add them all up, -10. Okay, number 9, approximate the integral from 0 to 8 of sine of radical x dx. N equals 4. We're going from 0 to 8. 8 divided by 4 is 2, so delta x is 2. They're asking us to find the midpoint. So use the midpoint, we're M4. So the midpoints are 1, 3, 5, and 7. So M4, which is an approximation of this definite integral, is 2 times the function values at the midpoints, 1, 3, 5, and 7. So plug into the function, 2 times sine of radical 1, plus sine of radical 3, plus sine of radical 5, plus sine of radical 7. Punch it in the machine, make sure you're in radian mode, 6.1820. Okay, and going all the way to 35. They're asking you for the exact answer by interpreting in terms of areas. Integral from -1 to 2 of 1 minus x dx. Well, here's what the graph looks like. We've got triangles. We know how to find areas of triangles. Okay. So positive would be this part, negative would be this part. So this area is 2, 1/2 base times height, 1/2 of 2 times 2 is 2. This area is always positive, is 1/2, 1 times 1, that's a half. So the integral is 2 positive minus a half negative, or 1.5. Okay. 37, integral from -3 of 1 plus radical 9 minus x squared dx. Okay, I have to digress for a moment, talk about radical 9 minus x squared. Y equals the square root of 9 minus x squared. Square both sides, add x squared. X squared plus y squared equals 9. That's a circle center of the origin with a radius of 3. Okay. However, I'm going from -3 to 0. So that means I only have this 1/4 of a circle. And then in the original function, they have me add 1, okay, which means the graph is translated 1 unit up. So -3, 0 becomes -3, 1. 0, 3 becomes 0, 4. So this is what I have. Okay, so I have a quarter circle here and a rectangle here. So the true area I can get by taking 1/4 of pi r squared and then adding the area of this rectangle. Okay, so the integral from -3 to 0 of f of x dx is, this is 1/4 of a circle, so 1/4 of pi times the radius squared. The radius is 3. And then this is a rectangle, which is 3 by 1. Okay, so that comes out to be 3 pi over 4 plus 3. Final answer. Okay. Problem 39, integral from -4 to 3 of absolute value of half x dx. Well, I just made a little table to see what it looks like. Okay, I decided to plug in -4, -3, -2, -1, 0, 1, and 2. Okay, this is what you get. Graph looks like this. This is -4, 2, 3, 1.5. So I can find the actual area under the curve by adding this area to this area. So this is 1/2 base times height, 1/2 of 4 times 2 is 4. This is 1/2 base times height, 1/2 3 times 1.5, 2.25. So the integral from -4 to 3 of absolute value of 1/2 x dx, 4 plus 2.25, 6.25 is my answer. Okay, going back to 5.2, number 6. Okay, estimate the integral from -2 to 4 with 6 subintervals using right endpoints, left endpoints, and midpoints. Okay. So we're going from -2 to 4. These are, by the way, half units. So this is 1. So this is 1, -1, -0, 1, 2, 3, 4. Okay. So let me just see if I can get you the function values. So that I said was 0, -1.5, -1, -1.5, -1, 0. Remember, each of these is half a unit. 1, 1.5, 1, 0.5, 0, -1, -0.5, +0.5. Okay, so the right endpoints are at -1, 0, 1, 2, 3, 4, and 4. Right. Left endpoints are at -2, -1, 0, 1, 2, and 3. The midpoints are -1.5, -0.5, +0.5, 1.5, 2.5, and 3.5, which is going to give me these. Okay, so delta x is 1 in each case. I like multiplying by 1. So it's the function values at the right endpoints, -1, 0, 1, 2, 3, 4. If you look at the graph, it's -1.5, 0, 1.5, 0.5, -1, 0.5. Add them all up, 0. L6, I want the function values at the left endpoints that I mentioned. Those are at -2, -1, 0, 1, 2, and 3. Here are the heights, 0, -1.5, 0, 1.5, 0.5, -1. You have to look at the book for that, -0.5. And then M6, 1 times function value at the 6 midpoints. Those heights were -1, -1, 1, 1, 0, and -0.5. -0.5 is my answer. Last one I'm going to show you was 34. Okay, so you have this semicircle and this integral from 0 to 2. Okay, that's just a triangle. 1/2 base times height. 1/2 of 2 times 4 is 4. From 2 to 6, that's, they said, is a semicircle. Underneath the x-axis, so it's going to be a negative number. The area is 1/2 of a circle, 1/2 pi r squared. 1/2 of pi times 4 is 2 pi. So the integral is -2 pi. Then the integral from 0 to 7, okay, so that's this, and this is a negative, and this is 1/2 of 1 times 1, which is a half. So the grand total for all three of these from 0 to 7 is 4 minus 2 pi, because that's below the x-axis, plus a half. So final answer is 4.5 minus 2 pi for problem 34. Okay. All right, so that was section 5.2.